Okay, so previously we had actually talked about finding, we used volume, we found volume by rotating a shape around either the x or the y-axis. And now we're going to find volume about a line. So this is a situation where our line is not necessarily going to be x equals 0 or y equals 0, but something different. So in order, you can read here, to rotate about a horizontal line, y equals c, we express our inner, that's our outer radius, in our inner radius as functions of x and integrate along the x-axis. So here we have y equals radical x, y equals 0, x equals 4, x equals 4 is here, excuse me, about the line y equals 4. So we're going to rotate this shape here around this this line here, y equals 4. So what we first need to do is evaluate what's our outer radius going to be. Well, our outer radius is going to be this minus this, right? So that's just going to be 4 minus 0. Well, what's our inner radius going to be? Well, our inner radius is going to be this minus this. So if I'm using like this space here, here's my r outer, here's my r inner, kind of. Right, so this minus this, or you can think too, your outer is this large one, and the inner is the smaller one, right? So your inner radius is going to be 4 minus the equation of this line here, which is radical x. Okay? Since this is perpendicular, since our discs, because we're still using the disc and washer method, right? In this case, it's going to be the washer method because we clearly have a hole here. Because it's perpendicular to the x-axis, we're going to use dx's. So our volume is going to be equal to pi times the integral. Well, if you wanted to, I'll write that in a minute. The integral from 0 to 4, right? Because we're still 0 to 4 here, of our outer radius, which in this case is just equal to 4 squared, minus our inner radius, which is 4 minus radical x squared, dx. So that's going to be equal to pi times the integral from 0 to 4 of 16 minus 16 plus 8 radical x minus x dx. If you want to fast forward here to, not watch me just integrate, I'm going to pause. I don't want you to watch me do that. Okay, if you want to see me do this, I don't know, I can demonstrate it in class, I guess, but it's just integration. And this ends up equaling 104 over 3 pi. That's the volume of what would essentially be kind of a weird shaped donut that would be created by doing this. So if you want, I'm going to write kind of the general formula here for finding this from, it would be volume is equal to pi times from a to b of the outer radius squared minus the inner radius squared. Hopefully you remember that from our last lesson. Okay, let's do another example. Y equals 4 minus x squared, y equals 0 about the line y equals negative 1. Well, this, we can use symmetry here because this shape is going to spin around, and you'll have, I guess, kind of another weird donut. These are all going to be basically just weird donuts. So our volume is going to be equal to, I'm going to use symmetry here and go from 0 to 2. Okay, so here I'm going to use 2 times pi times the integral from 0 to 2 of, well, our outer radius is going to be 5 minus, well, it's going to actually just be this. Our outer radius, I'll write it here, is going to be equal to 4 minus x squared, this equation line, minus a negative 1. And our inner radius is going to be equal to 0 minus a negative 1. Right? So that's that distance here for that inner radius. So this is, of course, just becomes plus, so you have 5 minus x squared, and this just becomes 1. So our actual formula for finding the volume is going to be 5 minus x squared minus 1 squared, right? I'm going to pause again, integrate, show you the end part. Okay, I'm back. I did the integration mathing part. So I finally get for my final answer 832 pi over 15. Okay, so we've used lines that are basically a y equals situation, but let's do a couple of examples with an x equals situation. So here, to rotate about the horizontal line, horizontal line, gosh, I can't talk today, x equals c, we want to express them as functions of y and integrate along the y-axis. So here, we're going to be rotating around here. Burp, burp, burp. All right, so we've got, oh, you know what I forgot to do? No, I didn't. Y equals x squared, y equals 4, about x equals 3. I did forget. I forgot to draw the line y equals 4. You can see it. Anyway, but this is what we're rotating, okay? We're rotating this around the line x equals 3. So, what's our outer radius? Well, our outer radius is going to be this, which is going, well, it's actually going to be 3 minus this line here, which is going to be, oh gosh, 1 second. Okay, so our graph here is y equals x squared. I need to actually know what this is in terms of x. Well, if so, x equals, right? X equals plus or minus radical y. That's what I need to have here. So this is going to be equal to negative radical y, and this is going to be equal to radical y. That will help me here. So the distance of my outer here is going to be 3 minus a negative radical y, and the distance of my inner radius is going to be, 3 minus radical y. Radical y. So now it's smudged. So now I can find my volume. My volume is equal to pi times the integral from 0 to 4, because I'm using my y-axis now, right? 0 to 4 of 3 plus radical y squared minus 3 minus a radical y squared dy. Okay, our disk here, we're gonna use dy as the height of that's dy. So I'm gonna pause. I'm gonna do the math part, and you'll see the end. Okay, and so when I finally get to the end of this, and I've done all the math integrating part, I get 12 pi times 16 thirds, which is equal to 64 pi. Okay, let's do one final example here, and I think you're kind of getting the hang of it now. Hopefully, we have y equals 2 radical x, y equals x, and we want to rotate this about the line x equals negative 2. So again, we want to find our outer radius and our inner radius. Well, our outer radius is going to be this distance here, right? And our inner radius is kind of going to be this distance here. All right. So this line is y equals x, and this line here is y equals 2 radical x. So our outer radius is going to be just negative 2 minus, my outer radius, negative 2 minus y. And my inner radius is going to be negative 2 minus, and I need to have this in terms of y, so y equals 2 radical x. I'm sorry, in terms of x, y over 2 is equal to radical x, so y squared over 4 is equal to x. So this is our inner radius here is going to be negative 2 minus y squared over 4. Okay, so now I can actually find my volume. My volume is equal to pi times the integral from 0 to 4. That's my point of intersection there, of negative 2 minus y squared minus a negative 2 minus y squared over 4 squared dy. Okay, pause for integration. Okay, and I do all the integration in math, and I finally get my answer of 96/5 pi. Okay, hopefully that makes sense. I probably could have thrown this in with disk and washer method originally, but I think it's nice to kind of take it slow and not rush too much. So if you have any questions, leave them in the comments, and I will see you in class. Bye!